Good morning students. Today we will discuss Theorem 8.6 and Theorem 8.7. So see children, Theorem 8.6. The diagonals of parallelogram bisect each other. So see children, here in a Theorem 8.6, the diagonals of parallelogram are bisect to each other that we have to prove. For that, consider quadrilateral ABCD, AC and BD are diagonals and intersect at point O. So see children, here figure of quadrilateral ABCD is given. So see children, this is the quadrilateral ABCD. Then AC is diagonal and BD is also diagonal. So AC and BD diagonals, they can intersect at point O. So see children, here in a given figure, this is the quadrilateral ABCD, this is diagonal AC, this is diagonal BD, and they can intersect at point O. Now we can measure the length of OA, the length of OC, the length of OD and length of OB. So see here, length of OA is equal to 4 cm, length of OC is equal to 4 cm, length of OB is equal to 5 cm and length of OD is equal to 5 cm. Here OA is equal to OC because they have same length 4 cm. OB is equal to OD because they have same length 5 cm. So after the measurement of all the length, we observe that OA is equal to OC and OB is equal to OD. So see children, OA is equal to OC and OD is equal to OB. So we can say that point O is the midpoint of both diagonals AC and BD. So see children, here OA is equal to OC and OB is equal to OD. So O is the midpoint of both diagonals. And we repeat this activity for other parallelograms. We repeat this activity with other parallelograms, and every time we find point O is the midpoint of parallelograms. This activity we repeat for other parallelograms, and every time we find point O is the midpoint of all the parallelograms. So we can say that, or so we can prove that diagonals of parallelogram bisect each other. That we proved. Now Theorem 8.7. If the diagonal of parallelogram, if the diagonals of parallelogram bisect each other, then it is parallelogram. It is the converse statement of Theorem 8.6. If the diagonals of quadrilateral are bisect to each other, then given quadrilateral is parallelogram that we have to prove. For that, consider quadrilateral ABCD and diagonals are bisect each other. Here we will consider one quadrilateral ABCD and thereby diagonals are bisect each other. So see children, here figure of quadrilateral ABCD is given. This is the figure of quadrilateral ABCD, and AC and BD are diagonals and they can intersect at point O, and both diagonals are bisect to each other. So OA and OC, they have same length. Same way OD and OB, they also have same length because both diagonals bisect to each other. And we have to prove that ABCD is the parallelogram. So see children, here diagonals are bisect to each other. So OA is equal to OC and OB is equal to OD. So triangle AOB congruent to triangle COD. Triangle AOB, see this triangle AOB and triangle COD both are congruent to each other by SAS congruence rule, and both triangles are congruent to each other. So angle ABO is equal to angle CDO. See, angle ABO means this angle and angle CDO means this angle. They are congruent to each other. And see children, they are alternate interior angle. And alternate interior angles are equal, then transversal intersect whatever two lines. These two lines are parallel to each other. Here AC is the transversal. AB and BC are two lines, and line AC intersect line AB and line DC at two different points, and alternate interior angles are equal. So AB parallel to DC because alternate interior angles are equal. when transversal intersect two lines and alternate interior angles are equal, then given two lines are parallel to each other. So here we proved that AB parallel DC. So see children, here angle ABO is equal to angle CDO. Both are alternate interior angle, and AC intersect AB and CD. So AB and CD both are parallel to each other. So AB parallel to CD. So same way, here AB parallel to CD we proved. Same way, BC parallel to AD also we can prove. So AB parallel CD. See, AB parallel CD. And same way, AD parallel to BC also we can prove. Here AB and DC both are opposite side of the quadrilateral and they are parallel. AD and BC both are opposite side of the parallelogram and they are parallel to each other. So we can say that quadrilateral ABCD is the parallelogram, and quadrilateral ABCD has one property. This property is the opposite side of any quadrilateral are parallel to each other, then given quadrilateral is parallelogram. Here in quadrilateral ABCD, both pair of opposite sides are parallel to each other. AB and CD, they are opposite side and they are parallel to each other. AD and BC, they are opposite side of the quadrilateral ABCD and they are parallel to each other. So we can say that ABCD is a parallelogram. So see children, this is the normal explanation of Theorem 8.6 and Theorem 8.7. I hope you can understand this. Thank you.